Folgers Marsh is a 17-acre salt marsh that's in very good shape. Salt marshes have a freshwater input, and that's exactly where we're at. There's a cattail marsh across the street, and where I'm standing is where freshwater, which is water that's not salty, comes into the marsh. So the salinity here is about 8.8 parts per thousand. Temperature is 19.6, and we've got more conductivity because we're using a conductivity meter to tell us what the salinity is. All salt marshes have what's called, or most salt marshes have what's called a salt wedge, which is salt water that creeps up along the bottom and fresh water that floats along on the top. So fresh water comes from rivers and streams, floats along the top of a saltier wedge that's coming in from the ocean. On each tidal cycle, that ocean will push closer into the salt marsh, and on the ebb tide, when the tide is going out, the freshwater wedge will move out. So when you're looking here in the water column, you're going to actually see that it's going to get fresher towards the surface. In this case, it's also not as basic as it was at the front of the marsh. We have about 6.5 pH, where we had closer to 7.3 pH at the very front of the marsh near where the ocean is. And our salinity here at the very surface is right at 0. If I lower it through the water column, we're going to have a salinity of about 8.9. And now I'm going to switch to my dissolved oxygen meter, and we can look and see what the dissolved oxygen concentration is. You might see too that toward this part of the salt marsh we have more cattails, and we'll talk a little bit more about that here in a moment. So right here I've got 5.3 to 4.4 parts per thousand. So this is very fresh water. Creatures that live here are going to be very different than they're going to be at the ocean side of the salt marsh. Salt marshes in this case are like an estuary where they've got fresh water at the one end and salt water at the other end. So let's see what our dissolved oxygen meter says. This is measuring the amount of oxygen that's in the water. This end of the salt marsh is going to be lots more oxygenated than the ocean end. We don't have as many anaerobic creatures. We've got more aerobic creatures, creatures that need oxygen to live. So this is a lot more fresh water that's coming in off of rivers and streams. It's going to be mixed up. It's going to have oxygen entrained into it. In this case, I've got nice cold water, and since I'm holding it close to the bottom, it's actually pretty low in oxygen. It's about 21.0% oxygen and about 1.6 milligrams per liter. A lot of that has to do with the primary productivity and all of the decaying matter that you see me standing in. All of this excess material is from the several storms we've had this winter, which has spread all of this eelgrass and cattails and decaying matter here. That's all decaying, and it's taking up oxygen as it decays. So hopefully you'll understand that salt marshes are a combination of fresh water coming into salt water, where every day a battle is fought between the harbor of the sea and the freshwater streams.